Alright, so here we are today for section 1.8. This is the last section from chapter 8. So we'll still talk about the functions, but today we'll talk about the inverse functions. So what is inverse function? First of all, you may remember that when we start discussing about the functions, at the very first we talked about the domain and ranges, because we said that in every function we have domain set, we have range set, and we have a relation between domain and range, which is basically defined by any function. Okay. Now, in case of the inverse function, what happens is this. Let's say you have a domain set in a regular function, right? You have a domain set, and most of the cases we represent it by x. Okay. Now, and you have a range set. Let's say this is the range set, which is represented by y in most of the cases, or f of x. Okay, or maybe I can write f of x, and we can see some relation between those. For an example, there is one member here which is relation with member one here, some kind of relations, right? And there are some relations which is impossible, because we know that we cannot have any relation from one domain to multiple range, right? Because that is a relation, but that's not a function. But what happens if you have a relation between x and y, let's say like this, but what happens if you swap x and y? For an example, you assume this is your domain set and this is your range set, still there is a relation that exists. If that is true, if that exists, then that function is going to be the inverse function of the first one. Now, again, in any function, we have a domain, we have a range. We know that there is a relation between domain and range. Now, if we swap the domain and range, that means this is going to be your domain and this is going to be range. If still there a relation exists, then that function is going to be the inverse function of the original one. Okay. Now in this section we'll be talking about all the inverse functions. Okay. But we know that from one point of domain or two relation with two different domain set, right?
Domain points, right? The range points. This is impossible in a function, right? But this is possible, right? From two different points, we will have relation with one range point. That is possible. But look at this carefully. If this holds, when you swap it, let's say this becomes your domain and this becomes your range, then this is not going to be a function. Because when this is a domain and this is a range, what is happening? From one point of domain or one member of domain, you have a relation to two different range points, which is a relation but not a function. So technically speaking, if you have a function for which there is an inverse function, there will be always something like this. For one point in domain, there will be exactly one point in the range. Meaning you should have something like this. For one point, there is one point. For one point, there is only one point. For one point, there is only one point. Then, for that function, there will be an inverse function. Because if you inverse it, that means if you swap domain and range, still that there will be another relation that will exist. Okay, you know, I'm just showing you the bigger picture. Mathematically, we'll use different terms and formulas and things, but technically, this is exactly what you are expecting for the inverse functions. Now let's see the official or formal definitions of inverse functions. Again, these are the same thing, but mathematical definition. Now, inverse function is called f inverse, and also sometime mentioned we write it f to the power minus I, but remember this is not power.
we just write the inverse function like this. So for an example, if you see f of x somewhere, and then in the same literature if you see f inverse of x, that means they're talking about the inverse function, which is basically the inverse function of f of x. But just remember, in general we use this to the power minus is what? For inverse to the power minus 1, and people assume that that means 1 over f, right? But that is not true in case of function. It's not like that. Okay? This is not valid in case of inverse function. Don't assume that. For an example, let's say if you have x to the power minus 1, you can write it 1 over x, right? So that is not true for inverse function, because it's just used to explain what is inverse function. Now also you remember, when you are taking function of inverse function of x, that is going to be x, of inverse function of f of x, that is still going to be x. Okay, so by definition. So it's something like this. So if you write this, it will be x. Technically it's something like you are cancelling out, but if you think like this, what you are saying is you are taking inverse, you are replacing x by inverse of x in f of x. You will end up with x. Or if you do the reverse, inverse of, still you will end up with x. Okay, these are some properties of the function and inverse function, because the domain of f is basically equal to the range of x. Because look at this, what you are trying to explain, you are by f of something, you are basically trying to find the range of f function, right? Look at this. When you write this, what are you trying to find? You are trying to find the range set, right? This means the range, right? So here you are trying to find the range of f set. But look at this. Range of f set is what? Is probably y. But when the x is replaced by f inverse of x, now f inverse of x is basically what? This is what? So for the inverse function, if you apply this to inverse function, what do you get? You will get basically the domain of x, domain x, because for this function, meaning I'm saying because the domain of f is basically the range of f inverse, because you just swap the domain and the range of those for those. Okay, so and also just again as we reminded that f inverse just used as a inverse function notation. Okay, it's nothing like f inverse equals to 1 over f. It's not the reciprocal function.
Okay. All right. So these are some relation picture, because as you remember that this probably will give you a bigger idea, because remember at the beginning of the section we started with a discussion like what is the relation, because you know as long as you have relation between two sets, we say it a relation, mathematical relation, but some of the relations are functions, some of the relations are not, right? Because there may be relation when you have one member in the domain set which has a relation with two members in the range set, which is only a relation but that is not a function. So this is basically giving you that idea that relation, a lot of things are relation, but out of those, some of those are functions. This is small this circle here, okay? And out of those functions, there are some which are inverse functions. Because as you know, some of the functions may be only functions, but they don't have inverse functions. Because as I said, that inverse, if a function has an inverse function, that means they have a one-to-one relation. Because one member in the domain will have one member in the range. These kind of relations are called one-to-one relation. And that's why we write it like this, 1:1. That means one-to-one. Okay? That means for one domain point, there is a one range point. There is one domain point, exactly one range point. Okay? But in general, in case of the regular function, for multiple domain points, there can be one range point. But in those cases,
if you swap it, then it will never be something like this. Let's say if you have this, what happens? This is still a function, because two domain point can have one range point. This is a function. Now think about it. When you swap it, let's say this is your domain now. Look at this. One domain point have two range. This is a relation only. This will never be a function. So there are some functions which are only functions, they don't have inverse functions. But there are some little set of functions which are one-to-one function and they have inverse. So it's something like this. If any function is one-to-one function, it will always have an inverse function. So that's why we wrote it like this. There are plenty of relations, because a lot of set might have some relations. Any pair of set have relation, but out of those, there are some set which has relation which qualify as a function, and out of those, there are some little ones which are one-to-one functions. They have inverse functions. We're just trying to show you a bigger picture. Okay. All right. So, and as you know, remember, again, that's the same thing, but we're just telling you again and again, every x, there is only one y. That means for every single domain point, there is only one range point. That's one-to-one. Okay. All right. So here is an example that what can be. So I think that's pretty much straightforward. So we just wanted to show you that one point has one. So I think the most let's see how we can get a inverse function from a given function. Okay. Let's say we are given a function and we want to find whether there is an inverse function. We want to find what is that inverse function is. Now let's say first of all, these are the formal steps. Okay. So step number one, let's look at as an example. I think instead of reading the step, I think let's look at the example first, and then I'm sure we will understand the step. Now let's say you are given a function f of x, okay, which is x squared minus 1, where x is always greater than or equal to 0. Then you have to find the inverse function. Now what are the steps? Step number 1. Look at the step number 1. Remember, you will always have the access to the slide. So you will have the slide. Make sure you understand. So step number 1, replace the f of x by y. So after that, we have y equals to x squared minus 1. We replace the f of x by y. Then step 2, we swapped or interchanged x and y. So we just replace the y by x and x by y. Then we solve the equation for y. To solve the equation for y, what do? We have to isolate the y, right? For this function, we found that y equals to square root x plus 1. The last step.
Replace the y by f inverse of x. Now when you replace the y by f inverse of x, you are done. This is a function which is basically an inverse function of the first one, original function. So it's a pretty much simple step. You just have like 4 steps. Number 1, you will replace f of x by y. Number 2, you will interchange x and y's, and then you will solve the equation for y, and then you replace the y by f inverse of x. All right, so let's see whether we can find this inverse function. Let's try this. So we are given a function f of x equals to x cubed plus 4.
let's follow those 4 steps and see whether we can find the inverse function of x cubed plus 4. You want to sign in? Anyone has the answer? Let's see what we have. What is the answer? Everyone has the same answer? Cubic root of x minus 4, right? Yeah, that should be the answer. Let's see whether we can find out the same answer. Okay, so we first replace the f of x by y. So we have, this is the step 1. In the step 2, what do? We interchange x and y. So this is going to be x, this is going to be y cubed plus 4. And then in step 3, we solve the equation for y. So when you solve it, you isolate y, which will be so you take the cubic root to isolate the y, and then you solve the equation for y, and at the last step you basically replace the y by f inverse of x. So f inverse of x equals to cubic root of x minus 4. Any question? I did it a little bit shorter because probably you can write a couple of lines to find the solution for y. Any question? There are some other examples too, so when you practice, make sure you look at those and see whether you can do that. So we'll do a test called horizontal line test. Remember, which is called horizontal line test and one-to-one functions. Now, first of all, we will probably know how to do the test. Now, first of all, why we want
to do the test? That's probably one of the questions. Now, as you have seen that we can easily convert from any function to its inverse. We can do that just following 4 steps. But one of the most critical questions we want to ask before we do this is this a function which does have an inverse? Because as we know that even if we have a function, it may not have an inverse function. So we know it, right? Because that function has to have one-to-one function, one-to-one property to qualify that it has inverse function. So by the horizontal line test, we will be able to tell that whether a function has an inverse or not. Now, that probably is the first question we want to ask. Now, if the function has an inverse, we can just follow 4 steps and find the inverse function, right? Now, so for this, we need the graph first for the function. Now, any function, when you see the graph, you will draw, so if you can draw a horizontal line such that it intersects that graph at 2 points, more than 1 point, that function is not a one-to-one function. That means that function does not have an inverse. In our example, look at the blue line. What is that function? Remember from the section where we learned some common graphs, and also we learned how to shift. What happens if you shift, if you move the graph, if you take the reflection of the graph, how the equation is changed. Remember that section? From that section we know that the blue graph is basically f of
x square, f of x equals to x square. Now look at that graph. So once you have that blue graph, you can easily draw a line. Look at the red line. You can draw the line which intersect the blue line at 2 points. Whenever you can draw such a line which intersects the graph at more than 1 point, then that function does not have an inverse function. That means that function is not a one-to-one function. More explicitly, that function has multiple domain points which has a relation with one range point, right? Multiple domain has one range point, and that's the reason why that is not one-to-one. Now let's look at these examples. Look at A. Look at the graph A. What do you think? Is that does it have is that a one-to-one function? Yes, because you cannot draw any horizontal line such that it intersects that line at 2 points. But you can easily draw a horizontal line for B, for sure, which intersected 2 points. You can see for C we have drawn a horizontal line which intersected the blue line more than even at 3 points. This probably will be more than 3 if we look at other part of the graph. How about D? Yeah, it's a one-to-one because you cannot draw more than one line here. You cannot draw such a line such a horizontal line which basically intersect the graph more than 1 point, right? Let's look at some more examples. Now, first of all, you'll be given an equation, and then you have to draw the equation. I'm saying you have to plot it. We know that how to plot. We can take points and we can plot it. But in addition to that, we also know that we can guess the graph just based on the equation, right? Remember, we know how the graph should look like. How the graph should look like of the square root graph. How it should look like. So the graph should start from here in general, just a regular standard square root graph, and it goes all the way to like this, right? But there is a shift. What kind of shift is this? Horizontal or vertical? It's a horizontal shift, right? Does it move right or left? It moves right. Right? When it is negative in horizontal, it moves right. And 3 positions right. So basically it will start from here, right? So basically the graph will start from here and it will go all the way like this. Now can you draw a horizontal line such that it intersects the graph more than 1 point? You cannot. That means this is a one-to-one function, and at the same time this has an inverse. Because both of those pop up at the same time. Inverse function will have that means the function is one-to-one, that's why it has an inverse, or vice versa. How about this one? This is an absolute function. How the graph should look like? V. Okay, now there is a there is a vertical shift. We know that. Horizontal shift. We know that. So, but just from the V, what happens when you draw a vertical line? Definitely it will have 2 intersections, because it doesn't matter even how you draw the horizontal line. In every single places wherever the graph is existing, there will be 2 intersections, right? Because the graph it will look like a V. It will start from the point will be here, so it will look like this V, right? So if you draw horizontal lines, it will always intersect the V at 2 points. So that means this is not a one-to-one function, and it does not have an inverse. So those things are coming into the picture right now, that we know the graph, how it should look like. And at the same time, if you sometimes forget, you can use your calculator, or you can just plot it. Just take like 5 points of X and draw 5 points of Y, and then probably you can guess how the graph looks like. But sometimes it's really tricky, because in case of the V, you might get 3 points here, 3 points here. You will not know that whether that's a V. You see what I'm saying? You probably will need more points. You will not be able to guess just from 3 points here and 3 points here. So you will not know exactly how the graph will look like, how you will be connecting those 6 points. So you know, so that's why we still want to know how the graph look like. Now, in case of the inverse functions, now here the blue and green lines, they are inverse functions to each other. Now, any inverse function is symmetric, or we would say they reflect, they are symmetric about y equal to x line. Now, what is y equal to x line? What is y equal to x line? Now, what do we mean by y equal to x line? Look at this carefully. Y equal to x line means, let me draw it first. Let's say we draw the y equal to x line. Let's say this is your graph. This is our x and y axis. So y equal to x line will be like this. Because at every single point in this line, y and x will be equal. Something like this. All the points will be like 1, 1, 2, 2, 3, 3, 4, 4. That's what I'm saying? Negative 1, negative 1, negative 2, negative 2. So if you look at this carefully, all the points are like this. Same x and y. Okay. Now this is going to be your x and y equal to x line. So the slope is 1, you know, and there is no y-intercept. That means, first of all, the slope is 1, and there is no y-intercept, means is basically passing through the origin. That's what exactly you see here. Now, in this line, so any two functions which are inverse to each other, they will be symmetric about this line. You see that they are symmetric. If you draw the line here, this side and this side will look similar. So any two any inverse functions to each other, they will be symmetric about that line with respect to that line. Okay. So based on that, we can, if we know one function and if we know that there is an inverse of that function, we can probably estimate the graph of the other line. Same example is here. Look at that red line. The red dotted line is the y equal to x line. Now let's say that there is a curve for the green line. If green line has an inverse, that must be like the blue line. Or if there is a graph or function which is a blue line, there must be another inverse function which will look like the green line. Do you see that? The blue and green line, they are inverse to each other, and they are symmetric about the red line. Do you feel it? They are symmetric about the y equal to x line. Now let's look at this example. This is an interesting example. Now first question is, we know that, I think we have seen it before, right? Reciprocal function 1 over x. So the whole graph is a reciprocal function. Now the first question is, what is the inverse of this? Now let's say you draw, can you draw something which is mirror? Now what does it mean by symmetric? That's probably an interesting. Now in case of the symmetric,
what happens? This what happens. Look at this. In case of the symmetry, this what happens. Now if in one function there is a point AB, for that point in the other graph there will be a point BA. Right? Because you know the domain and range are just swapped. That's why. For an example, in one graph, if you have a point 34, in the other graph you will always have a graph, but you will always have a point 43. Now, look at this interesting thing. Now, for an example, let's say, what is this point? Let's say this point is half 2, right? Let's say this point is half 2. So what does it mean? This means that in the symmetric graph, there will be a point 2 half, right? Now let's see what is 2 half. 2 half. That point is already here. Look at every single point. Let's say this point. What is that? That is probably 1/3 3. So in the symmetric graph, there should be a point 3 1/3. Now look at 3 and 1/3. 3 1/3. What is that?
That means, first of all, this is an one-to-one function because it's symmetric. Additionally, this itself is the inverse of this function. So that means if you take the inverse of f of x, it will be same. This is an exceptional situation. Even if you try with our 4 steps, we know how to find the inverse, right? Let's check with the 4 steps just to make sure that whether we understand it right. Let's check with the 4 steps that we have. What is the step number 1? We replace the f of x by y. And then step number 2, we exchange x and y. So now we have x equals to 1 over y. Now we solve the equation for y, right? Once we solve the equation for y, we will have, right, once we solve it. We know how we get that, right? You multiply both sides by y first, and then you divide both sides by x. So this is what you get after you solve the equation. Now you replace y by f inverse of x, and this step 4. Look at the original equation and the inverse original function and the inverse function. They are exactly same. This is an exceptional case where the inverse function and the original function is exactly same. Any question here? How about this? First of all, is this one-to-one? Because you're going to draw any horizontal line such that intersects this graph more than one point, right? So that's definitely an inverse function. Now, can you draw any? How do you draw that inverse function? Now, first assume there is a line here which is y equal to x, right? And then this point will be here, right? So you just have to assume that the points are flipped. How about that? Let's say this point. What is this point? It's 3, 0, right? So for this point there will be a point 0, 3, which is here. 4, 4, 1. So there will be a point 1, 4. So 1, 4 is
here, right? So let's say we take this point and then this point. Let's take another point here. So what is this point? It's 5, let's say it's a little bit less than half. Okay? So there will be a point half 5. So a little bit less than half 5.
So I think you can draw the line here, right? Which will be the symmetry. So all you need to do is you just take a couple of points from here and flip x and y. Okay? If you have a point 3, 5 there, so there will be a point 5, 3. But before that, always make sure that that's an inverse. That is a one-to-one function, because as long as there is a one-to-one function, that will always have an inverse function. Okay. How about this? Is this an inverse? Is this a one-to-one function? Yeah, definitely it has. It's a one-to-one function. Can we draw it? Just you know, take those points. For an example, you have one point. That means what? There will be also a one-to-one point, right? Let's say there is a -1 point. So there will be a -1 point. What do you mean? Is this the same graph? How the graph will look like? It will not be same, I think. It's y equal to x cube, and it will be cubic root of x, right? Cubic root of x. So, but anytime, just take couple of points, like 5, 6 point, and then just flip the x and y. So I'm saying you don't have to memorize any graph because it may be something else or whatever. So just based on that, pick 5, 6 point and then flip the x and y, and once you have 5, 6 point, you will be able to guess. And again, that will be symmetric to, always symmetric to x and y. However the graph will look like. Alright, so here is an application of the inverse function. Let's say we have a function which converts x degrees Celsius to an equivalent temperature in Fahrenheit. Now, is it a one-to-one function? Why or why not? How to answer that question? Is this a one-to-one function? Now, first of all, so far, what do you know about the one-to-one function? How do you know it? You know when you have a graph, and you can do the horizontal line test. Now, to do that, you first need the graph of this line. Now, do you see the line is familiar to you? Remember the y equal to mx plus b. You have any question? Yeah. So let's see. So if you think along that line, because you know we are trying to draw the line. Let's say, okay, we are trying to draw the line. So let's say y equals to, because f of x equals to y, so the slope is this plus 32. So this is your slope, and this is the b-intercept, okay. Now remember, we can also find the equation from a and b-intercept, right? So at this point, we know this is the b-intercept. We know this is the b-intercept. So let's say we know that since this is the b-intercept, what will be the point in the here? That will be, let's say, 0.32, right? Now, how do you find the y-intercept? Sorry, the x-intercept. So you will assume that y equals to 0, right? If you assume y equals to 0, what will be the value of x? It will be 5/9x plus 32 equals to 0, right? Because to find the intercept, we have replaced the y, x-intercept, we replace the y by 0. So 5/9 equals, x equals to 32, negative 32, and then x equals to negative 32 times 9/5. How much you get here? What is this in fraction?
Something close to 60, negative 60. What is there?
Anybody can do the math? What is that? How much is that? 0.6. So let's say it's negative 57.6. So that means the point is here. So the coordinate may be the negative 52.60, right? So at least you know that the line will be like this, because this is an equation of a line. And first of all, from here you know this is a one-to-one function, right? As long as that is a line, you cannot draw any horizontal line which can intersect it more than one point. If it is a regular line, except the horizontal line. Now, so we know that, and we can also answer why or why not. So this is a linear function, so which represents a line. So it's a one-to-one function because you cannot draw any horizontal line which intersects this line at more than one point. So we know that answer. So it's one-to-one function. This is a linear function. That's the straight answer. But you know, we can always answer like that. But at the same time, since we are doing it for the first time, I tried to show you there is a line exists. But in general, any linear function will represent a line. And for that line, you cannot draw any horizontal line which intersected more than one point. What is your question, sir? Oh, just by doing this math. Minus 32 times 9 divided by 5. We just solved this equation. Oh, minus 32. Yeah, do you see this? Yeah, just solve this for x. Because we just find the x and just a point. I'm just trying to show you that. But remember, as long as that is a linear function, it will be a line. It may be anywhere, but if it is a line, you know, you cannot draw any horizontal line which can intersect it in more than one point. You cannot intersect any horizontal line, any linear function line, except that is an horizontal line. You cannot intersect it in more than one point. Now, since we know this, can we find a formula F inverse? That means, can we find the inverse function? Right? We have 4 steps. You can always do that and find the inverse function of this, because as long as this is a one-to-one function, we know that there is an inverse function exists for this function. So 4 steps. What is the answer? So x minus 32, and then what? Here. Okay, now we got the inverse function. Now the most important part, since this is an application question, interpret what it calculates. Now what did you find? Now look at the first function. The original function, look at the original function. What it does, it converts the x degrees Celsius to a Fahrenheit, right? So the inverse function should do the reverse. Original function takes degree Celsius as an input and gives you degree Fahrenheit as an output, right? So the inverse function just does the reverse. It takes degree Fahrenheit as an input and it will give you degree Celsius as an output. So the original function is a converter from degree rate or degree Celsius to degree Fahrenheit. The inverse function is a converter from, and you know, just think about that why this is an inverse, there is an inverse function exists, or why this is a one-to-one function, because
every single temperature in degree Celsius has exactly one equivalent temperature in degree Fahrenheit, or vice versa. They have just one-to-one mapping. Because for an example, Nobody will come up like this. Okay, for 40 degrees centigrade or 45 degrees centigrade, the temperature in Fahrenheit is 42. There is no such answer, right? Because there will be two separate temperature points there too. So that's why that's like a one-to-one mapping between those two temperature scale. And that's why the function is one-to-one function, and the interpretation is it was just, it just reversed. So it's important because sometime in real life you might have a formula for something, but you want the reverse. So you can just use the formula, and as if it is a one-to-one function, just use the 4 steps and convert it back to another function which just does the reverse. Okay. So, we tried to show you, I think we already have that answer. So, we are just getting the inverse function. Now, let's see whether we can pick one of these questions. Maybe find an equation for... Let's try this one. So, we are given one function, which is 4x minus 5 over 2. Let's say whether we can find the inverse function. We know that this is a very simple one, because I just want to make sure that we have some practice here. We are just completing one section one day, so we don't have that much time to practice. So this is the function. Original function is 4x plus minus 5 divided by 2. What will be the f inverse of x? So what is the answer? It's 2x plus 5 divided by 4, right? Right answer is C. Everyone has the right answer, C? Alright, so let's stop here for this section.